webinar workshop on plant ID. This week, we're going to get out of that darn Asteraceae family and get into another family, equally as fascinating though and important, the Asclepiadaceae, or though now you'll learn just a little bit the Apocynaceae. So milkweeds, of course, I think pretty much everybody obviously can probably identify a milkweed, or I'm guessing, or most of you can certainly pick one out, at least, tell it that it's a milkweed species at least. Milkweeds are pretty easy to identify, at least to genus. And of course, they're pretty friendly and well-known plants. I mean, every kid's probably, learned about the monarch, larva story and how important it is for monarchs and the mimicry that happens with the alkaloids that the butterfly larvae get from the plant, and probably taking those follicles, those fruits of milkweeds, and open them up and blowing at them to push those and blow those seeds with those tufts of hair out into the wind. So it's a pretty kid-friendly plant, but there are some challenges when it comes to identifying the species, certainly. I think in most cases, if you've got the flowers, then you've got a pretty good shot at identifying it. But as we're going to talk about a little bit as we go along, vegetatively, it can be pretty difficult in some cases. So just looking at these two species you see here, anyone, I'll give you a little pre-workshop quiz. Anyone recognize these? This one over here on the left, for example.
Amplexicala?
No, not quite. It would have more cream yellow flower color if it was Amplexicala. I can see
Sullivantii.
Sullivantii, right.
Oh,
they have similar leaf bases. Amplexicala will probably be a little bit more clasping than what even this is here, though. But yeah, this is Sullivan's milkweed, Asclepias sullivantii. Now this one might be a little bit harder. This one's real common. Well, I wouldn't say real common, but it's certainly one that if you're on a decent prairie at least, and it's a wet music to music prairie in the right range, you'd have a chance to see. The one on the right's a little bit more hard to come by. Anyone have a guess on that one? It's really hairy on the stems. That's one clue. Of course, the greenish white flowers, another clue. It's in that group. This is Asclepias lanuginosa, the woolly milkweed, which is, I think it's either threatened or endangered. We'll see in just a second when we look at the table. All right, so Asclepias is a Greek word for the Greek god Asclepios. It's spelled a little bit different, but Asclepios was the Greek god of medicine and healing. That's where the genus name comes from. Excuse me. And there certainly are some medicinal properties for the genus. Native Americans used it for a variety of things. Let's take a look at the next slide. So where does Asclepias fit into the big picture? So and you're going to get kind of caught up here. This isn't completely out yet because the Flora of North America has not yet been published on this family. But the traditional view has always been, of course, that the genus has been in its own family, Asclepiadaceae. This is a worldwide family. As you can see, it's more common, more diverse in tropical, subtropical parts of the world. Almost 315 genera and 2,000 species were recognized in that family. In the Midwest, again, because we're quite a ways north of the tropics, we're not real rich in the family. Asclepias is the most numerous genus that we would have here. Gynecom and Medallia are a couple other genera that occur in the Midwest. Gynecom is blue vine, and Medallia is climbing milkweed. Both of these are vines, which distinguish them from the milkweeds. But that's the old view, the older traditional view. Flora of North America, although it's not been published yet, you can go in and you can look at future volumes to be published, and you can see how they're going to treat Asclepias in that when it does come out. and like many other floras have done now, and what the Angiosperm phylogeny website has also done, again, due to the genetic work that's been done, Asclepias is now going to be subsumed, or the family Asclepiadaceae is subsumed by the family Apocynaceae. So it'll be, in the new system now, it'll be one of 400 genera in this larger family, quite a few more species. And when we look at the, excuse me, the Midwest, some of the genera then that we would have, we'd still have, of course, Asclepias and the other two here, but now, of course, Apocynum. The dogbanes are going to be the other genus that is the most commonly seen, at least in our part of the woods here. So it might be worth it to take a quick look at what kind of separates those two. These are some characteristics that are common to both the older Asclepiadaceae family and the Apocynaceae. Both milkweeds and dogbanes then basically have that milky latex. They both have simple leaves that are opposite or whorled, although dogbanes generally don't, and their margins are entire. That means there's no teeth or anything along the margins. Both milkweeds and dogbanes have perfect flowers that are actinomorphic, and that means that the symmetry in the flowers is radial, meaning it's got a center, and then the flower parts, the petals and the sepals, radiate out in all directions in an equal way. They also have all of these things in common. They both have two carpels in the female part of the flower, the pistil. Ovaries are distinct. I threw some more terms in the glossary, which I'll show you in just a little bit, but that simply just means that they're not fused. The ovaries are not fused to each other like they often are. So that's something that's pretty unique to the family. But although the ovaries are not fused, the stigmas are fused to each other. And connate is a way of saying that. That's the fancy way of saying it, I guess, in a sense. And both groups have 5 stamens. Both groups have seeds that we can describe as being comose. That means that they've got this tuft of long, slender hairs that arise off the seed coat, off of one end of the seed coat. The fluff that you see on those seeds is what we're referring to there. So all of these things are all things that make dogbanes and milkweeds look the same. These next few things, there are some differences. There's somewhat slight differences, but some differences. And so again, the red things are Asclepias, that's the milkweeds. The blue things are the dogbanes, that's Apocynum. And now we're going to look at the sepals. In the milkweeds, the sepals are mostly always fused. That's again what connate means. In the dogbanes, they can be, and we're talking about the entire family, they can be either fused or not fused. That's again what distinct means. The petals, again, are mostly always fused. Now in the milkweeds, those corolla lobes are usually reflexed, meaning that they are actually pointed downwards. And that's pretty distinctive and separates the milkweeds from the dogbanes. The petals are also fused over here, but they're not reflexed. They go up like most petals do. The stamen filaments in the milkweeds are fused to each other and are also fused to the corolla tube. It's a part of a really complex structure. And again, that's one thing that's, I think, makes milkweeds pretty easy to distinguish from other plants, is that they have a very complicated and very different looking flower. And this is part of it. We'll take a closer look at this in just a bit. The anthers, again, adnate that also means fused. The difference here, and this is in your glossary, when we say something's connate, it means things are fused, but we're talking about the same things. So petals being fused to petals, for example, we use that term. But if anthers are fused to a stigma, those two are two different things. So we use a different term to mean fused there. Anthers are adnate because, again, they're fused to some other part that's not like them. In Apocynums or the Apocynaceae, the stamens are more distinct. They're not fused, but they are inserted onto the corolla tube on the inside. And rather than the anthers being fused to the stigma, the term adherent simply means the anthers are close by and near to the stigmas. Sometimes they kind of stick to them just a little bit, but they're not truly fused to them. All right, then the last character, there's a few more characteristics here again that separate them. Pollen in the milkweeds are in these packets or large masses called pollinia, and we'll see what that looks like. Whereas in the Apocynaceae, they're either just separate by themselves or in groups of 4. And then the fruit. All the milkweeds always have this fruit called a follicle, which is a type of dry fruit that it's dehiscent, meaning it will split open on its own. It will open up on its own, but it splits just along one line to open up. And that's how, of course, those seeds come out. In the Apocynaceae, they can have a follicle, and most of the dogbanes do, but other members of the family might have other types of fruits. And of course, a berry and a drupe are 2 types of fleshy fruits, like a grape or like a peach. All right, then the last thing here is that there are some really distinctive differences between milkweeds and dogbanes, and that's what these are right here. Milkweeds have these structures here: corona, hoods, and horns. They have this thing called Gynesium, and they have their nectaries in this stigmatic chamber. We're going to focus on the first 2 mostly here, because that's really what makes the milkweed flower so different. So here's a little sketch I made of a milkweed flower, sort of showing a cross section through the flower, and it's done to be sort of in a diagrammatic way. So I mean, I'm not trying to actually represent an actual milkweed flower from a particular species. It's done to be more instructive. So it's, we've got sepals, and for some reason my advanced is kind of slow. So the perianth, again, the perianth refers to the flower parts that are sterile, are not reproductive at all. And that's, of course, the sepals and the petals. And the sepals are those structures right there I just colored in, and the petals are those. And again, you can see that both of them are reflexed and drooping or pointing down. Then we can look at the andrecium. Now, the andrecium refers to the male part of the flower, and so, of course, that involves the stamens. And here, the stamens are those structures right there. We can see 2 of the 5. They are basically sort of embedded into this tissue here. The filaments help to form this tube that we see right here, because there's a wall right here, and there's a wall right here, and it's open in the middle. So this is basically a tube right in through here. And the anthers, of course, are up here at the top of the filaments. That's an anther, that's an anther. And then a part of the andrecium includes the corona, which is these structures right here. So the corona is another part of, well, it's actually a little bit more like the perianth. It's another type of sort of sterile flower part. Is considered to be an appendage that comes off of the corolla, basically the fused petals. And again, this is all fused in with the lower parts of the filaments here. So these are called the hoods. And there's going to be 5 of those, just like there's 5 petals, there's 5 hoods. And in many of the milkweeds, there's these structures called horns that come up out of the center of the hoods. And you can see them very easily from the top, looking down onto the flower. We'll see some pictures of those. And the corona and the hoods are all often very important flower structures that are used to, again, help determine which species you have. All right, then the female part of the flower is called the Gynesium. And the Gynesium then is represented here by 2 carpels. Remember we said the carpels are separate. you don't see them fused there. The carpels are not fused to each other. They're separate down here. The styles are also unfused and separate from each other, but the stigmas are fused together. And the stigmas, and as well as the upper part of the filaments and the anthers, are all fused together to make this structure called the stigmatic disc, which is what that is right there. Then finally, the gynecium then is this term that is something that applies mainly just to the milkweeds, Asclepias. It also is a term that's used for another family, the birthwort family. But the gynecium is all of this that I just highlighted with the dashed line. So it's all of this structure that's basically its combination of the some parts of the andrecium and some parts of the gynecium fusing together. And again, we can see that also some parts of the basically the perianth, because we think of the corona, the hoods here, as part of the perianth, part of that corolla tube, part of that is fused in here as well. So it's a very complicated structure. And if you ever get a chance to, and it's easy, you know, to find a common milkweed, grab some common milkweed flowers sometime. And if you have can get a hold of a scope or something, throw those flowers underneath the scope and start looking at things there. And you'll be somewhat amazed if you haven't done that yet, because it's a very interesting flower. So here again is an actual flower right here, and we can see some of the things I just talked about. Things are all named here. We're going to look a little bit more closely at what's going on here with the stigmatic disc up here, and learn a little bit more about where these anthers are, a little bit how pollination works. These are not really anything that's that important in identifying the species, because you really can't see much of this, really. It's all kind of embedded into the tissue of that stigmatic disc. But again, we've got some styles right there, the red part, the upper part of the styles come up, and then again, the stigmas, which are at the top of the styles, are again fused into this structure called the stigmatic disc. We got the stamen filaments that again form that tube, help to form that tube that surround the styles there. And the anthers are, again, those structures there. Now, in each anther, there's going to be 2 Pallinium. These are the little packets of pollen grains, masses of pollen grain all stuck together. And you can see what happens is that the pollinia in one stamen, this one right here, is joined together with the pollinia of an adjacent stamen over here through these structures right here. This black structure that I highlighted, this black structure right there, that's the corpusculum. It's a glandular structure. It sits right above this stigmatic slit. We can see a stigmatic slit right here. You can see a corpusculum right there. Another stigmatic slit right here. Another corpusculum right there. Same thing down here. Here's a stigmatic slit. Here's a corpusculum. Another one right here. There's 5 of them as you go around the stigmatic disc. And they are, the corpusculum joins to the pollinia on either side of it by these translator arms. These green structures right here, those are called the translators. And then again, the stigmatic slit is this, well, it's not that wide, really. Again, I'm just drawing this so you can see it, but you can kind of see what one looks like right there and one right there. So pollination, again, is very complicated, and I don't have a lot of time to go into the details here, but basically what has to happen is that an insect, and it's primarily going to be butterflies, moths, species of Lepidoptera, and probably primarily bees and wasps that are the main pollinators. As they are roaming around the top of this flower, there's nectaries that are in these corona hoods. Nectaries are in there. There's also sometimes some nectaries in the stigmatic chambers inside the stigmatic disc. So they're probing around looking for nectar. they accidentally get their foot in the stigmatic slit, and that gland is sticky here. It latches onto their foot. When they pull their foot out to get away, that pulls the translator arms out, pulls these two pollinia out through the stigmatic slit, and that whole structure then, the pollinarium, which is the corpusculum, the translators, and the pollinia on the ends, that all gets carried by the insect, hopefully to another plant of the same species. And by luck, by coincidence, again, that insect probing around for nectar accidentally somehow sticks that leg into the stigmatic slit of another plant and deposits the pollinia in there on the stigma of that plant. So it's kind of a low probability type of pollination event. Here's another quick diagram, or shouldn't I say diagram, an actual picture of the top of a milkweed flower, and you can see again all the parts there labeled nicely for you there. All right, let's take a look at the, I'm going to get out of this and briefly and pull up your handout, which I'm just going to scroll through this part right here and come to the table here. So again, this is the table I put together for you on the, well, there would be 17 species of Asclepias that are in Iowa now. You can see that I've done something a little bit different from the previous tables. Many of the Asclepias are prairie species. And so you're going to see lots of them colored in yellow here, again, because they're grassland or prairie species. And because of that, that means many of them have biogeographical distribution maps in the book by Christensen and Muller, the Iowa Prairie Plants book. And so I think it's really important, again, that if you're doing any restoration, that you have access to these maps, because again, I feel these are the best information we have on the probable native ranges of these plants in our state, again, before we came along and started tearing everything up and started mixing things up. So sand milkweed here, and again, of course, I keep the Bonap map so you can see the distribution of the species in the big picture, looking at the entire country. And we can see again, so this isn't Plexicollis, this is the sand milkweed. This one is really pretty distinctively found just on really dry prairies, sand prairies for the most part. It has some distinctive leaf bases that are clasping pretty much at the base. That's one good characteristic for it. The flowers are usually kind of a cream color. And there's usually just one umbel, just one large umbel of flowers at the top of the plant. We'll see some pictures of it, of course. Here's the distribution in Iowa. And again, so again, I'll just briefly tell you what's in this table, because some of you may not have been in a workshop yet. And so these tables I put together tell you in this column right here, what the nomenclature would be, what it is for flora of North America. But as I just said earlier, flora of North America is not done yet for the Asclepias. So we don't know exactly what this will be here. I'm pretty sure it's going to be Asclepias and Plexicollis, but I can't put that there really until the flora of North America is actually out and it's not done yet. Then the other thing in this column is the status, which just tells you again, whether it's native or non-native, and if it's endangered or threatened. And then the Iowa coefficient of conservatism. This is a number between 1 and 10 that reflects the affinity for the other species for really high, pristine, natural ecosystems. The higher the number, an 8, 9, or 10 is going to reflect a species that at least a group of botanists felt describe again this highly conservative nature. Then conservatism in that sense means that the plant is very conservative if it really is only found in the most pristine, the most natural types of environments that we have left. The lower that number, the more weedy it would tend to be, and the more the species responds very positively actually to human disturbance. So we can see two numbers. The original number that came out in 2000, the first time the list was published in the year 2000, and then the revision, which was is basically coming out like now, 2020 or so, was when that revision was basically done. It got bumped up. You can see from 4 to 6, and the H means that we have a high level of confidence that that 6 is a fairly accurate number. Then Eilers and Rosa is the nomenclature in Eilers and Rosa, the checklist of Iowa plants, which is the publication we have for Iowa plants, the common name that most often is associated with the plant. Again, the yellow means that it's a grassland species. There's some habitat descriptions here, which come from a variety of different sources, the Iowa map and the Bonap map. All right, so this next one, Engelmanniae, this one is in Eilers and Rosa, as you can see. And you can see over here on the Bonap that there's like 3 locations in western Iowa, supposedly, but those were all misidentifications. I checked those out a while back. Deb Lewis and I checked those out and discovered those were misidentified specimens of Asclepias stenophila. So this is not in Iowa. It's not present, although Eilers and Rosa says it is. Exaltata poke milkweed is a eastern Iowa species, as you can see here. And it's obviously to the northeast and far to the east of us. It is a forest species, poke milkweed. We'll see pictures of these as we go along. This just means that there isn't a map. This is not in Christensen and Muller, of course, because it's not a prairie species. So I put this Iowa map together, basically just using this map right here. Hertella is the prairie milkweed, or the tall green. It should be green, not green milkweed. Again, it's mainly an eastern Iowa species, although there are some locations up in northern Iowa. I see it mainly in southern Iowa. This one is, again, a species with greenish whitish kind of flowers, pale green. And its leaves are really narrow and lance-shaped. You can usually pretty much identify this one by its leaves. Its old name is Asclepias longifolia, variety Hertella. And we've got a wetland species. That's what the blue means right here, swamp milkweed, pretty much statewide. And you can see it occurs over lots of country, basically. It's state of 4. And this one is a pretty easy one to identify as well, vegetatively. The Nuginosa, this is the one that was on the front slide there. This is a state threatened species. It has a coefficient of 9. What this is showing over here is the distribution in Iowa based on the Iowa Natural Areas Inventory. So again, there wasn't a map in Christensen and Muller because it's not a common species. And the different locations here again show counties that have records, but any one of these that's in red means that there is no record of a population still being extant in that county since 1960. So basically we look at that as at least probably a historic record. We don't know I can't say for sure without checking in some of those sites, but I would say there's a possibility that's been extirpated from that county. The blue ones are all counties that do have a record since 1960. And that one I photographed right there was up in Dickinson County just a couple of years ago. The one that's in this purple one right here in Jasper County, I think is one that I'm not sure about the identity on that one. It's the habitat description that the record shows for this really wet, seepy area, and that's not where this milkweed grows. So I'm not sure that's the correct ID there. Medii is the federally threatened. That's one of our most important prairie ones, of course, prairie species. Mead's milkweed, state endangered and federally threatened. It rates a 10. The only locations I know for it are down in southwest Iowa. Again, there's some old records over here, but it's probably one of our most restricted ones, certainly. Ovifolia. And also the other thing that you see here is the ones that are highlighted with shading here are going to be ones that I'm going to put into the pictorial key. The ones that are not highlighted. These are, again, our milkweeds that are so hard to find and so rare. You're not likely to come across these at all. And so, again, the idea is to try to focus more on the more common ones, the ones that you're more likely to see. And this one's not a real common one. I've only seen it once or twice. I photographed it up in one of these counties up here many years ago. But and it probably is a species that probably should be listed. We'll see if that happens coming up. Going to be reviewing the list of threatened and endangered species and maybe making some changes to it in the next month or so. Purpurescens, this is what I would know we might say is the savanna milkweed or open oak woodland type of species, and sort of the distribution in Iowa sort of reflects that as well, being mainly in the southeastern one half of the state. Quadrifolia is a four-leaf milkweed, which is a way southeastern Iowa species, a forest species. Spiciosa is a showy milkweed. This one is also threatened at the state level. I photographed it up here in Mills County, or not Mills, but Clay County. You can see it is way more common out to the west of us in the Great Plains and even way out to the west coast. This species is very similar to common milkweed and very difficult to distinguish from common milkweed unless it's in flower. And in some ways, it's ecologically said to be somewhat similar to common milkweed too, in that it's some people would claim it's a little bit more of a ruderal or weedy species. Stenophila is our another one of our state endangered species. A narrow-leaf milkweed is really mainly in the Loess Hills. There's a record for it in Guthrie County, and population still there, but really dry sites. This one is an easy one to kind of confuse with Rutiflora, except that Rutiflora is going to be a lot more common, the green milkweed. And here's four more. So Sullivantii, Sullivans, pretty much statewide, common milkweed statewide, butterfly milkweed, I should say, statewide, and world milkweed pretty much statewide as well. Again, you can see world and common have a rating of 1, a coefficient of 1. And finally, Rutiflora, the green milkweed, pretty much statewide, I would say, looks like, and it's another species of dry prairies. And then Viridis. So Viridis was not in Others in Rosa, and I should have put that right here. That's a mistake. Viridis came to light as a species being in Iowa. Well, there's some records going back a few years, I think, but became more recognized, I guess, and verified by Mark Fishbane, who's doing the milkweeds for Flora of North America. He's from Oklahoma. And then I checked on a population down here in Ringgold County. This population in Ringgold County is just barely in the state of Iowa. It's just north of the county line. So yes, it is in Iowa. This again, it probably will need to be given at least a threatened status at least. As you can see in Bonap, it doesn't show it in the state of Iowa because there weren't any records known, but you can see it comes right up in southeast Nebraska, northern Missouri. And so not surprisingly, there are a few populations just across the border. But again, this was not one that you're going to run across. So it's not going to be one that's included in the key. This just tells you again what those fields are. Information is given to you. Now, milkweeds are said not to really hybridize very easily, very often. There's not very many reports of hybridization going on in general, although I did find all these 4 hybrids, and all of them involve common milkweed, Syriaca. These are publications, papers that are reporting a hybrid between Syriaca and another species. So it does happen, but apparently not very often. And probably a little bit because of the pollination method in milkweeds is fairly specific. These again are species that are near us in an adjacent state, but not, at least so far, known to be in Iowa. All right, then the other thing you're going to have here is, we're going to go look at that on the PowerPoint, but you have a key here, which I put together. This one does include all of the 17 species. Doesn't have Engelmanniae, of course, because Engelmanniae is not in Iowa, but it includes Viridis right there, and Stenophila, of course, all 17 species. And this is pretty much the source of the information that we'll be using, in the pictorial key. The pictorial key is just a little, maybe a simpler way for most people to use the key, rather than trying to use a more technical version of the key here. But if you want to, use this key, you certainly can. And if you think you might have one of the other species, the more uncommon species, then you should use this one. And then finally, the last thing here is this glossary, which again, I'll point out, these are terms we use for the shapes of things. These are terms over here we use for the surface of stems or leaves or bracts or filaries or whatever it might be, fruits even, types of hairiness. These are terms for the margin of a leaf. These are terms that describe how leaves are attached to stems, if they have a petiole or not, or other more specialized attachments. Added a couple more. These are terms that describe the apices, or the ends of things, like the ends of leaves or the ends of petals or other things. These are terms that describe the bases of things, the shapes of the bases of things. And then there's a bunch of just definitions here. And I've added a few again that reflect again the Asclepias that we're looking at, the Gynesium and Follicle, are a couple of terms that, of course, have to do with today's group. All right, so you've got that. Now let's jump back to this, and we'll take a look at the pictorial key. So I've got 13 species. 4 of them, again, were deemed just too uncommon, not likely you would come across very often, of course. So these 13 somewhat more common species are in this pictorial key, and they are separated into 6 groups: A, B, C, D, E, and F. And the first, and almost all keys do this in terms of making the first cut in milkweeds, we use the leaf arrangement. Group A here, most of the leaves are alternate. In B, C, D, E, and F, leaves are generally opposite or whorled. Now, one species, and it's going to be the green milkweed, Viridiflora, is going to key out in group A, and it's also going to key out over here, and I think it's in group C. It keys out both ways, because that one can vary so much that you could come across an individual that you would say, oh, this is alternate, or you could come across an individual and you say this is opposite. And so you have to get to the right one either way. Viridis is also that way, but Viridis again is the spider milkweed, and it's that one that is just barely occurs in southern part of Iowa. So when we look at group A, then we're going to separate these 3 species out, and we're going to do it really easily by taking out butterfly milkweed really easily here, of course, by the color of the flowers. So the corollas, obviously, this is a very easy milkweed to identify. I don't think any of you need any help probably identifying it. It's pretty easy to identify even vegetatively when you get a good feel for the gestalt of these leaves, and the fact that they are pretty crowded, alternate, of course. There's not much of a petiole there, really a little tiny short one. So butterfly milkweed comes out, and some photographs, of course, of the close-ups of the flowers here. And then the other couplet here is the corollas, of course, greenish or pale green. And the other thing, of course, is butterfly milkweed has clear sap, whereas all the other milkweeds have milky white sap. And so we use that as well to separate out these 2. And then green and prairie milkweed, Viridiflora and Hertella, are separated out basically on the size of the flowers, on the length of the corona hoods, on the length of the corolla lobes. So all basically measurements of flower parts. Here are some pictures of the green milkweed, Viridiflora. Then on the next slide, Group A, these are the prairie milkweed, Asclepias Hertella. And I think, again, Viridiflora, the thing to point out here is that the leaves can be really variable. Here's some leaves that are wider. Here's some leaves right up here that are much more narrow. These leaves here are sort of approaching, getting close to the size of Asclepias stenophila, but they're yet still just a little bit too large really to be that species. Stenophila has leaves that are even more narrow than this. Let's see. Hertella has doesn't have any horns, so there's a few other species that are that way as well. But that's one thing that it's not in the key, but it is something to note. Possibly, no, that's an easy thing to find and recognize whether or not there's any horns that come out of the hoods or not. And so the next one here, again, this one here, Hertella, again, there's no horns coming out of the hoods on these flowers. And I think, let's see, I'm checking another document I've got here real quick. Yeah, Viridiflora doesn't have any horns either. So neither of these two have horns. That's just something, again, to know, again, because if you do have the flowers, that's an easy thing to look for and see. Neither of them have horns. All right, then, so we've got Group A taken care of. Now we're Groups B, C, D, E, and F. Again, these have leaves opposite a whorled. We're going to separate off really easily, again, one species, whorled milkweed, of course. So the leaves are nearly all in whorls. And these, again, leaves are really very linear. They're very narrow, only about up to 2.5 millimeters wide. This is Group B, just a single species in it, whorled milkweed, which is pictured next here. And this too is a really easy one to recognize vegetatively, of course, because the whorled leaves. You just need to pull off a leaf to make sure you've got some milk there, because there are some other plants, of course, that could have whorled and narrow leaves, but it's going to have the milk. It'll have the whorled leaves, and so it's in Group B all by itself. Then Group C, D, E, and F are going to be then leaves that are just opposite. Or if whorls, and there is going to be one species in this group that does have whorled leaves, if whorls are present, then the blades are much larger than these leaves here. The blades are at least 5 millimeters or more wide. And we're talking about the leaf blades there, of course. All right, now we're going to go to C, D, E, and F. And here we're going to take this group and separate off one species into Group C. And that, again, is Viridiflora, the green milkweed. You would come this way, again, if you happen to have one that had opposite leaves. But here you can really separate it out now from the rest of these, because, again, it doesn't have any horns. The corona or the hoods do not have any horns coming out of them. Whereas over here, D, E, and F do have a horn. Okay, now we're going to take D, E, and F over here then. And again, you have to go back and look at Group A pictures to see some pictures of that one. We've already shown those. D, E, and F, the ones that do have horns, the corona hoods do have horns, and they're very visible, very easy to see. Again, you can see some right down here. We're going to separate these two into these two groups here, D, and then E and F. And we're going to look at the corona hoods. This is a little bit harder in the sense that there is some overlap here. What we're saying here is that those hoods, remember the corona hoods, those are those structures that are actually coming up. That's these things right here. Remember, the petals are going down. The corona hoods are shorter than, or at most just slightly longer than the gynostegium head. And the horns are extended well beyond the tips of those hoods. The horns really stick out of these hoods by quite a ways, very, very conspicuous. And again, these horns are barely or just a little ways taller than the gynostegium head. That's going to be group D, and that's going to have 3 species here. Sand milkweed, the plexicalis, this one right here, that we're seeing right here. And then 2 more, exaltata, the poke milkweed, and incarnata, the swamp milkweed. All the rest of them go into groups E and F. They're going to have these hoods that are clearly longer than, much taller, clearly longer than the gynostegium head. The horns are going to be visible, but they're kind of arched over the gynostegium head, and they're not really extended that far beyond the tips of the hoods. They're not that conspicuous. You can see them, but they don't stick up like these do right here. So this is the sand milkweed, of course, again, and we can see the bases of these leaves are, they're sessile, and the bases of the leaves sort of clasp or wrap around the stem just a little bit there. The leaf margins are pretty wavy. Those are all good vegetative characteristics for it. There is usually just one umbel. And again, so what the inflorescence, we didn't talk about this, but the inflorescence for Asclepias is an umbel. And what an umbel is it means that all of the flowers here are on these stalks, these little pedicels. And these pedicels are all arising from a common point. If the flowers and the pedicels that they're on, the flower stalks, the pedicels, all come from a common point, as we see here, that's an umbel. All right, so again, we're going to separate sand milkweed out by the leaves being sessile, the cordate and somewhat clasping leaf base, the wavy margins, versus the other 2 are going to have leaves that are petiolate. And guess that again means that there's a petiole there of at least 3 millimeters or more. The leaf bases are more narrowed or rounded, maybe slightly cordate, but not nearly as clasping looking as these are. And the leaf margins are flat. They don't have that wavy waviness that you see here in this plant right here or down here. I threw a few pictures of some follicles in here. Sometimes the follicles are fairly helpful in distinguishing which species you've got. Okay, then when we look at the 2 other ones down here, poke versus swamp, these are easy to tell apart. First of all, poke is a woodland forest species, and swamp, of course, is a wetland species. Although you could have, I suppose you could have a sort of a shaded wet area where swamp would be. But the corollas are different colored. The poke is going to have white to greenish corollas, the flower petals, and swamp is going to be pink to rose purple. Also some differences in the sizes of the flowers. And poke, the flowers are on these pedicels that are longer, much longer, because they actually somewhat nod. The umbels then kind of nod or droop downwards, versus swamp milkweed, the pedicels are much shorter and the umbels are more erect. And we'll see that on this next picture here. So here is poke over here on the left. And actually, all of these right here on the left, these are all poke. And then these are over here all swamp. All right, let's, I guess, move on. And now we're just down to these last 2 groups. We're down to 6 species. We're going to separate group C and F here. E are plants that have the ventral surfaces of the leaves pretty moderately to densely pubescent. There's going to be no doubt about it. There's going to be pubescence there. The pubescence can be different types. Villus means that they're longer. more spreading types of hairs. Tomentulose means that they're shorter and a little bit more like a short carpet of hairs, but nonetheless, very obvious hairs in all four of these. And then group F over here, the ventral surface is glabrous, meaning no hairs, or glabrate, meaning sometimes it could just be, some really just sparse pubescence, maybe a little bit along the leaf margin, maybe a little bit along the midvein. So group F is going to be a couple of slides away. We got to deal with group E right now. We got 4 species in group E, and so they're all keyed out right here. And the first one here is showy. The first thing to separate these is we're going to separate showy out of these 4 by looking at the corona hoods. This is something really distinctive about showy. These hoods that you see right here are really, as it says here, long and tall, large, 9 to 15 millimeters long, very narrowly lanceolate, very much narrowed down to a very acute tip. Very different looking hoods than in most other milkweeds. Much larger, much more lance shaped and longer, much more pointed. That's going to be good for showy. Now, without the flowers, though, as I said, showy is going to be tough to separate from common milkweed. I do have one characteristic that might work. Scroll down here and find it here. No, actually, that's going to be for separating purpurescence from common. Don't have a good one to separate common from showy. Haven't been able to figure out anything that would work vegetatively very well. Even the fruits look a lot alike. So you pretty much have to have flowers to be sure that you've got showy. Showy is a lot less common than common. So, most of the time you're going to be in places, again, go back to the map, and again, showy is only really found up in the very northwest part of the state. But if that's where you're at, then, and you're on a decent prairie, then you might have either one. All right, then, so the other ones, the other 3 then have the corona hoods, smaller, shorter, somewhat different shaped. Then we're going to separate out purple milkweed next by looking at these 2 characteristics right here. The margins of the hoods without prominent lobes. The corolla is very reddish purple, this deep red, dark purple. If you've got flowers, then this is going to help quite a bit to help distinguish purple from these other 2 down here. These 2, this characteristic, I'll show you what we're talking about here in just a little bit. But on what we're saying here on purple is that the margins of the hoods, the edges of the hoods, do not have any kind of little lobe-like shape or structure. And that is the case down here for both oval leaf and common. Oval leaf and common are very similar to each other in many ways. They both have these little triangular lobes that occur along the edges of the hoods about at the midpoint. And they both have corollas that are white to greenish white, lavender, maybe even rose or pink. So quite a bit of variation there. Then how are we going to separate oval leaf from common milkweed? On the basis of size, pretty much, the size of the corolla lobes. Now remember, when we're talking about the corollas, these are the petals, of course, and the lower portion of the petals are fused together to form a tube, but the upper portion of the petals are not fused, and those are those corolla lobes that you can see, again, being reflex and pointing down. When we talk about corolla lobes, we're talking about just the length of those lobes, just the unfused portion of those petals. So difference in size here by quite a bit. And the follicles are quite different as well. That's the fruits again. Here's a picture of purple. Now purple and common, purple's right here, common's right here. These 2 are going to be a little bit difficult if they're not in flower. They both have pubescence on the bottom side of the leaf. That doesn't, that's not going to help. to look at that. What I have found is that purple milkweed, which is again, I would say a little bit more of a like a savanna or a woodland species, a little bit more shaded, compared to common milkweed, the leaves on purple are more acute. That means the tips of the leaves, go back and look at the leaf tip, again, pictures I showed you in the glossary, but are a little bit more strongly pointed with more of an acute tip, and with less prominent pinnate venation. The pinnate venation is this venation that comes off, coming off like this. These secondary veins here, less prominent pinnate venation in purple than compared to common. Those characteristics might help you get an idea which one you've got if all you've got are leaves. All right, so here again are pictures of both oval leaf, and here is that little triangular structure. These red arrows, all these red arrows here are pointing to that little triangular, this thing that we were just talking about right here, these little triangular lobes. That again, this is what technically can separate oval leaf and common from purple. Purple does not have those lobes, the margins of the hoods without those lobes. Oval leaf and common have a pair of sharp little triangular lobes at or near the midpoint of those hoods. And there's, you can see one right there pretty easily in this picture. You can see this one, really can see it well because you're looking at it from the side. This one here, you're looking down at it more from the top, so it's a little bit harder to see. These are both oval leaf. Here's common over here. And here you can see the veins here are more strongly marked out here, I think. So that's another thing I was talking about. But here again, that little triangular structure, again, on the margins of the hoods right there on common. All right, we got two more and we're done. So group F, we're going to just separate, and these two are pretty simple. We're going to separate Sullivan's milkweed and four-leaf out here. Pretty easy to separate out. They're both also, I didn't put in here, but both are also in different kinds of ecosystems. Sullivan's is, again, a pretty decent prairie grassland system, and four-leaf is in a forest. But we can separate them out on the leaf arrangement. Sullivan's going to have opposite leaves that are going to be pretty much sessile or very close to subsessile. Which means just the tiniest, if at all, a little tiny petiole. Leaf bases more rounded, somewhat heart-shaped. Corolla lobes much larger compared to the corolla lobes down here. The coloration, we can see there's some differences here. Sullivan's usually is this rose pink color, and four-leaf usually more of a whitish color, but there can be some variation. Four-leaf can have corollas that have a little bit more of a pale pink color to them. So, there is a little bit of overlap there. But the main thing here, of course, is that in four-leaf, the leaves are opposite, and generally speaking, but here's the thing. There's a couple, usually at least one or two, middle stem, mid-colline means the middle of the stem, internodes. The internodes is that portion of the stem between nodes where the leaves are attached that are very reduced. And thus that means then that there's two sets of paired leaves that are practically on top of each other. You might be able to distinguish the tiniest bit of internode there, but because of this, they appear to be a whorl of four leaves. It looks like you got four leaves there that all attached at the same node. Technically speaking, they're not quite attached at the same node. It's just that the two nodes are very, very close to each other. And there can be either one or two of those whorls of four leaves each then. And these leaves usually have a petiole that's pretty distinct. So and if you look at the follicles, again, there's a big difference in the shapes of those as well. You can see that the follicle of Sullivan's is a lot less tuberculate, warty, with a lot less sort of little weak spines on it than what common milkweed is. All right, I think that pretty much does it. Just a little bit over 8 o'clock. So I guess if we've got some questions, we can try some of those.
The only one I see right now is how do you measure the height of a flower?
How do you measure the height of a flower? Yeah, so that's a good question. When you're talking about the height of the flower, what you would want to do is you'd want to go all the way down to where the sepals are, attached, because where the sepals are attached, that would be the base of the flower. Now you can't see it in these, it's underneath. These are the petals, and then the sepals are underneath these petals. We can't see them, but you could pull this up out of the way, and you could see this, and then pull the sepals out of the way. You could see where the sepals are attached. Wherever the sepals are attached, that's where you start. Then you measure up to, I would say you measure up to the top of the hoods. Top of the hoods, although I've not seen any of the floras that they've actually clearly describe that as the correct way to take the flower length. I think that's what you see a lot in milkweeds is not so much the flower length. I know there were a few measurements of flower length in here, but they tend to use the length of the corolla lobes more, because that's very easy. That's from here down to there, from about right there down to there. So again, it's just this lobe right here that's not fused with the other lobes. That's a lot easier measurement to make than the length of the flower. All right, well, if that's it, thanks again.
One more.
Oh, got one more, okay.
Yeah, it just came in. What's the biggest difference between Sullivans versus common?
Between Sullivans and common. Okay, I would say that Sullivans is glabrous. So here's Sullivans right here again. I didn't put that in here, but the leaves are going to be really glabrous. They're even going to be somewhat glaucous, if you remember that term. They can be, which means it kind of might have a little bit of a bluish white waxiness kind of covering to it. And common milkweed, they're always going to be hairy. Here's the ventral surface of common milkweed right here. There's lots of really short tomentose little hairs here on this ventral surface. The other thing you might notice is that it seems like on Sullivans sometimes this mid vein is more of kind of a dark purplish color, I've noticed. Also, another thing on Sullivans I've noticed is that, and it shows it somewhat here, is the leaves tend to kind of be a little bit more vertical upwards than on common. Now they're not so much right there. So again, these things all vary, but as a whole, Sullivans is usually pretty easy to distinguish from common without the flowers, just on the basis of the leaves. Also, again, we're talking about sessile to subsessile leaves on Sullivans. And when we go back to common usually has little petioles here. See that right there? They're not real long, but there's clearly enough of a petiole there to say that there is one. That's a good question, because these two can co-occur together on the same prairies and look somewhat alike due to the flowers and just the shape of the leaves, the general shape of the leaves. Again, look at the fruit of common here. These sort of soft spines and kind of a warty appearance for the fruit of common, whereas on Sullivans, it's just lesser amount of that. It doesn't have nearly the density of those. I call them soft spines, basically, because they are soft. They're not that hard.
Okay, I think that's all we got.
All right. Well, I get 2 weeks off, so I need a little bit of a break. But in 2 weeks, I guess we're, what is it, Lance? Is it mints?
Yep, on the 15th, and then Sedge is 2 weeks after that.
So in 2 weeks, we're going to take a look at, now that's going to be a little bit different with the mints. It's going to look at the entire family and look at just some of the more common genera and some of the common species. We're not going to be able to look at the entire family, not in 1 hour, that's for sure. So I'm just going to pick on a few of maybe 15 or 20 of the more common mint species. And kind of the same thing with the sedges too. The sedges, there's over 120 sedges in Iowa. We're not going to have a key for all of those, that's for sure. I'm just going to pick out 20 of the more common species that you're going to come across, you know, if you're spending much time out. So that'll be in 4 weeks, sedges. All right, I'm going to get out of here and say hi to a few people. And I guess there's only 20 on, so hi, Diane. Hi, James.
Thanks a lot, Tom. Really good.
Thank you. Glad to see you.
Very,
join
very
in.
nice. Very, very well done. Thank you so much.
Hey, Diane Porter, I like your what you do on Iowa plants on Facebook.
Thank you.
Appreciate that.
Yeah, you've always got some nice pictures of things there.